to try something neat? Take these two fingers, now hold them on the side of your neck, right next to your throat. If you hold them still for just a moment, you'll start to feel something bumping around in there. That is your pulse, the feeling of blood moving through your body. And that means you're actually feeling your heart beating. Your heart is always beating, all day and all night, even when you're asleep. It can never take a break because it has a very important job. It moves your blood all around your body. And your heart can do that because it's actually a muscle. You have muscles all over your body that help you move, like muscles in your legs that you can use to run and muscles in your jaw for chewing yummy food. But your heart is the hardest working muscle of them all. Now, make a fist with your hand. That's about how big your heart is. It may seem kind of small, but it's incredibly strong. And it's the constant squeezing of your heart muscle that keeps all that blood flowing. But why does your blood have to move around in the first place? Well, you can think of your blood as working kind of like a delivery truck. It carries lots of what your body needs in order to keep going, especially oxygen. You've probably heard of it before. Oxygen is the gas in the air that people and a lot of other animals need to live. When you breathe in, you're bringing oxygen into your lungs, and your blood is there to soak up all that oxygen, and with the help of your heart, send it all over your body, to your head and to your feet, and everywhere in between. As your blood gets pumped around, all of the different parts of your body take the oxygen from it, and they use it to do their jobs, whether that's making your leg muscles move so you can run, or helping your stomach take care of that sandwich you had for lunch. But your body also has a bunch of stuff that it needs to get rid of, especially a gas called carbon dioxide. So after your blood drops off its shipment of oxygen, it also picks up that waste and hauls it off. When your blood gets back to your heart, it gets pushed to the lungs once again, where the blood drops off the carbon dioxide and picks up more oxygen. So when you breathe in, you're breathing in oxygen that goes into your blood. And when you breathe out, you're breathing out the carbon dioxide that your body has gotten rid of. Now, it sounds like a long journey, but your heart can pump blood to every part of your body in less than 1 minute. And your heart beats at least 100,000 times every day. So at any point during your day, your heart is sending blood to your lungs and out to the rest of your body and back to your lungs again all at once. That's some serious work. But have you ever noticed your heart beating faster when you've been running around for a while? That's your heart working extra hard. When you're running, jumping, and playing around, your body needs more oxygen and other nutrients to do that extra work. So your heart has to work harder to send all of those good things to the parts of your body that need them, and to get rid of all the extra waste. So the more you exercise your body, the more you exercise your heart. Now, who's up for some jumping jacks to get our hearts beating faster? And if there's something that you'd like to learn more about, just let us know by asking an adult to help you. Leave a comment below or email us at kids@thescishow.com. And we'll see you next time.
Okay, the body in space. So we've learned all about our body, how it is on Earth. But what if we were to go to a different planet? Some of you may want to be astronauts. How would that affect your body? Alright, let's read. It says, the human body isn't exactly the same on Earth as it is in space. Of course, we know that gravity plays an enormous part in the difference. So gravity is what keeps us on our feet on Earth. But there are other things that factor into how the human body behaves while in space. Here are 3 amazing facts that describe how the body acts and even changes while in space. Did you know the body can actually grow taller while in space? That's crazy. That's right. Because of the absence of gravity, the human spine has the ability to expand, causing the person to grow taller. As interesting as this is, and maybe even awesome for someone that wants to be taller, they return to their normal height once they return to Earth. Another intriguing fact is that astronauts have a hard time sleeping because cosmic rays flash through space. Once they close their eyes to get some rest, they continuously see the rays pass through their vision. So, if you don't like going to bed at night, this could be the job for you. Finally, the heart changes its shape and size while in space. The cardiovascular system actually changes altogether. This is the system that includes the heart. Without gravity, the amount of blood pumped out of the heart is decreased. A human's blood pressure is also lower while in space. If you're thinking about becoming an astronaut, there is a lot that the body has to do to get prepared for each voyage. Astronauts prep for months and even years in advance for a mission. Once the body is in shape, the astronauts have to keep their fitness up while in space too. They complete hours of exercise each day to maintain muscle mass and bone density. So that's what happens to your body in space. It's kind of crazy. All right, let's answer some questions about what we just read. Okay, write my name on the top as always. Number 1. Which word means the same as absence, as it is used in the passage? Let's see, where did it say absence? Okay, absence. Like if you're absent in school, what does that mean? Does that mean your dogs, stretch, loss, or gain? It means you're not at school. Loss. So you're not learning, you're not at school, you're losing your education. Number 2. What makes it hard for astronauts to sleep in space? So it talked all about sleep. We know they don't have gravity, but that doesn't affect your sleep. Cosmic rays are flashing by their eyes. They pass through their vision. So it is B. Number 3. True or false? A human's blood pressure is higher in space. Let me check back. I don't remember that one. Let's see. A human's blood pressure is lower while in space. So false. 4. How do astronauts prepare for a mission into space? They exercise and work out. Number 5. In the space below, write 2 facts from the passage. Make sure you write your answers in complete sentences. Let's see. Something I thought was really interesting was that they grow taller in space. Ducky. Ducky. Okay. Look, this is Ducky. This is my cat. I'm going to sleep. Excuse me. Okay, I'll write under it, I guess. So astronauts. You can't write under it. Ducky. I know. You're very cute. Okay, astronauts grow taller in space. So that was an interesting fact that I enjoyed. Let's see, what else was there? I'm going to look back in my article. Let's see. Oh, the heart. So the heart changes shape and size. So those are my 2 facts.
The final frontier. And for anyone unfortunate enough to be sucked out an airlock without a spacesuit, it will definitely be the fatal frontier. It's an old Hollywood trope. Humans inside a flimsy spacecraft have an accident of some type, and now the hole's been breached and everyone is about 2 seconds away from becoming human popsicles, or having their eyeballs explode. But is that really what happens to you if you stepped out of a spacecraft unprotected? Hello and welcome to another episode of the Infographic Show. Today we're taking a look at what would happen to your body in space. The most obvious problem you're going to have if you're sucked out into space is a lack of oxygen. Space is a nearly perfect vacuum, meaning there's not much gas to breathe in, let alone breathable O2. So if you find yourself aboard some space disaster, then you clearly should hold your breath and try to claw your way to safety, right? Wrong. That would actually be almost instantly fatal for you. As we mentioned, space is an almost perfect vacuum, and if you tried to hold your breath, you would be pitting your own chest muscles against the strength of space itself, and that's a fight you're going to lose. The oxygen in your lungs will immediately expand and rupture your lungs, being released into the circulatory system and ripped out of your chest, along with large parts of your now shredded lung tissues. So instead of holding your breath, you want to breathe out as completely as possible and make sure your lungs are empty. Don't worry, your brain will continue to remain conscious for about 15 seconds, and you can survive up to 2 minutes with little risk of permanent damage. With no atmospheric pressure squeezing down on your body, the next thing to happen will be the vaporization of water in your body. In a normal situation, water molecules are constantly being blown off, but by being repelled with their air molecules, the water remains in equilibrium with the air. Without any atmosphere, though, water will begin to evaporate throughout your entire body, causing you to start swelling like a naughty kid inside Willy Wonka's chocolate factory. You'll eventually swell to about twice normal size, but because human skin is incredibly elastic and durable, you won't burst like a giant meat balloon. If you get rescued at this point, you'll actually return to normal and you should be fine, though we wouldn't recommend it. If rescue isn't forthcoming though, then you're going to be in incredible amounts of pain. And if you were hoping to instantly black out due to a lack of blood pressure, then we got some bad news for you. Your circulatory system is so robust that it's able to keep your blood pressurized even in the vacuum of space. So as you swell up like a party balloon, you can look forward to retaining full consciousness as the blood keeps on pumping, at least until the oxygen stored in your blood runs out after 15 seconds. Moisture on the exterior of your body, though, and in places like your eyes and tongue, will immediately begin to boil due to the lack of atmospheric pressure. Yet this isn't a hot type of boiling, but rather a very violent form of evaporation. So you won't cook yourself alive either. If you were ejected into space in direct line of sight of a star, then you can expect to receive an incredibly bad sunburn on whatever side of your body is facing that star, thanks to unfiltered solar radiation. Depending on how far you are from the star, though, you might not receive enough heat to be seriously burned. But if you went for a stroll outside the International Space Station's airlock with no spacesuit, you could expect a severe and very immediate sunburn. You'll likely also be bombarded by huge amounts of cosmic radiation, especially if you're outside the protective magnetosphere of a large planet. Our suggestion is to spin rapidly. That way you'll be crispy nice and evenly. We all know space is cold, roughly 2.7 Kelvin, or negative 270 degrees Celsius, or negative 455 degrees Fahrenheit. You'd probably expect that your corpse would then rapidly freeze without any protection, but actually, you can stay relatively warm for a pretty long amount of time. That's because your body and skin is a pretty excellent insulator. And because space is a vacuum, there's nothing to lose heat to via convection or conduction. Here on Earth, we're constantly surrounded by atmospheric gases, so when it gets cold, they're able to leach heat from our body and carry it away, making us cold. In space, though, there's no medium to lose heat to, so your core body temperature would remain warm for a decent amount of time. Once you're dead, though, well, you're not going to change much for a long time. On Earth, we decompose as we're eaten up by the bacteria inside of us, billions of tiny, hungry little life forms just waiting to eat you alive that keeps your body in constant check throughout your immune system. But once that immune system fails, those bacteria finally have their chance to turn you into a buffet, and they gorge themselves while rapidly procreating. Think about that next time you buy some probiotic yogurt. You're just making those little bacteria stronger, and they're patiently waiting for your immune system to slip up so they can eat you from the inside out. In space, though, the extreme radiation and temperatures will kill that bacteria before it can consume much of your body, leaving your corpse perfectly preserved for millions and millions of years. If you're close to a star, you'll mummify, much like an ancient Egyptian. Only when aliens find you millions of years later, you'll actually be in a lot better shape than them. So, if you know anyone really vain in your life, you should recommend they die in space. What other strange places and what they would do to your body would you like to know about?